Hello and welcome back to this channel. Dear students, this session is for revision of two-port network parameters. It is unit number 3 from the subject electrical circuits. I have already created few videos related to this unit. I will share the link in the description box. Do watch those videos. Presently, this is the revision lecture. I will be telling you some important tricks to memorize the derivations, then some important tricks to solve the numericals and so on. I have made a list of parameters. These are the 4 important parameters. What is expected? You should know the defining equation of each and every parameter. It is simple. Once you know this thing, you can attempt any type of derivation. Let me briefly explain you what is the two-port network. As the name indicates, there are 2 ports. So input port is denoted by 1 dash, output port is denoted by 2 dash. These are the fixed notations. I1 is input current, I2 is output current. This is a symmetrical network. That means we can well interchange input and output. So both the currents, input current and output current, are shown flowing towards the network. V1 is input voltage. Another name to this is driving point voltage. V2 is output voltage. Another name is load voltage. So, as I said, these are the defining equations of the parameter. Now, how to attempt the derivation? If the question is like this, derive the defining equations for Z parameters, then you should know these defining equations. You have to derive the parameters. That means you have to derive values of Z11, Z12, Z21 and Z22. I will show you one simple calculation. Suppose I want to calculate value of Z11. How to think? In equation 1, let us say this is equation 1. In equation 1, we have term Z11. I need to calculate Z11. That means I have to make this second term 0. Second term contains I2. I2 is output current. So, condition 1, I will write like this. So, this is case 1 or condition 1. I2 is equals to 0. Current is 0 means you can well say output port. I2 is related to output port. There are 2 ports, input and output. So I2 is 0 means output port's current is 0. We can well write it like this: output port open circuited. So when I2 is equals to 0, put I2 equals to 0 in equation 1. This term gets vanished. So remaining equation is V1 is equals to Z11 I1. From this I will get Z11 is equals to V1 by I1. Write it like this, mark a vertical line and write the condition I2 is equals to 0. It is read like this: Z11 is V1 upon I1 when I2 is equals to 0. How to write the name for this? Z is impedance. 1 stands for input side. So it is input impedance or driving point impedance. Let us do one more calculation. Suppose I want to calculate this parameter Z21. Z21 is in equation 2. Say this is equation number 2. Again same logic. I have to make I2 is equals to 0. So if I2 is equals to 0, remaining equation can be written as V2 is equals to Z21 I1. Therefore, Z21 is equals to V2 upon I1 when I2 is equals to 0. How to give the name? Z is impedance, 1. 2 is output, 1 is input. So it is output to input. That means it is reverse case. So it is read like this: it is reverse transfer impedance. Why impedance? Because Z notation is there. Why reverse? Because it is from 2 to 1. Why transfer? Because it is not 1 1 or 2 2. It is, the numbers are different, so it is transfer. So the name is reverse transfer impedance. Likewise, you can do the calculation of Z12 Z22 by making I1 is equals to 0. Same logic is applicable for Y parameters, H parameters and ABCD parameters. Keeping in the mind that let us say I want to derive for H parameter. So how will you be thinking? Suppose initially think like this: I want to calculate H11. That means I have to make second term 0. Second term contains 0. So write the condition V2 equals to 0. If you put V2 is equals to 0, this term vanishes and you will get H11 is equals to V1 by I1. This is the hybrid parameter. Likewise, you can do the derivation if you knows these defining equations of every parameter. Now I have already created a separate video on the calculation of Z parameter, so I won't be wasting more time as far as Z parameters are concerned. But I will tell you simple trick. If there is a T network is like this. This type of network having the shape of English letter T is simply known as a T network. if it is a T network and if it is asked to calculate the Z parameter, then how to do it? Let us assume some values, say this is 100 ohm, another is 100 ohm, and this is 50 ohm. Then the formula is Z11. You don't have to do any calculations. Directly formula are there. If you are doing you are calculating Z parameter, and if you have a T network like this, so Z11 is see, this is terminal 1 dash, this is terminal 2 dash. To make the thing simple, I will mark current. Always and always, input current is denoted by I1. Direction is like this only in this chapter. I2 is output current. Direction is again like this. Stick to these directions. You are not allowed to make changes in the directions. Now formula is Z11 is addition of impedance where I1 flows. I1 is flowing through 150. So I will write 100 plus 50. Then Z22 is simple formula, addition of impedance where I2 flows. I2 is again flowing through this 150. So it becomes same 100 plus 50, that is 150. And last calculation, Z12 is equals to Z21 is equals to common impedance connected between 1 and 2. So what is the common thing between loop 1 and loop 2? It is 50 ohm. So answer is 50 ohm. One more thing you need to remember. After doing the calculation, after attempting any problem and after doing the calculations, if you are getting the value Z11 is same as Z22, the network is said to be symmetrical. This is the condition of symmetry. Similarly, if you are getting Z12 is equals to Z21, the network is said to be reciprocal. This is the condition of reciprocity. If the T network is not there, something else network is there, then keep in mind, always and always for Z parameters apply KVL, Kirchhoff's voltage law. As I mentioned, I have separately created video on Z parameter. Do watch that video. So I will explain the calculation of other parameters. Consider one numerical. Suppose the question is, this is the given circuit diagram and it is asked to calculate Y parameters of this network. What I said, if you are supposed to calculate Z parameters, use KVL. Do remember this concept. On the same lines, if it is asked to calculate Y parameters, use KCL, that is node analysis, Kirchhoff's current law. The things are pretty simple. Keep in mind the basic things. Input voltage is denoted by V1. So at this point I have V1. At this point output voltage is V2. These are fixed notations. Same way, this is input current I1, which is again fixed, direction is fixed. Similarly, this is output current I2, whose direction and this notation is fixed. For the remaining branches, one more thing, this is the dependent current source, whose value is given as 2I1. Now, for these two branches, currents are not given in the question. So I need to assume some directions as well as notations. Let us say this current I will denote it by I3 and this branch current I will denote it by I4. Of course, these are assumed directions. If you interchange it, it will not make any difference. Now, what I'm saying, I have to use KCL, that is node analysis. For such type of numericals, related to Y parameters, we know that V1 is voltage at input end, V2 is voltage at output end. This voltage, there is no standard notation. I will denote this voltage by notation VA, just for the simplicity. This node is same as node voltage V2, so this voltage is V2. Now, we are aware how to apply KCL. The basic formula of KCL is incoming currents is equals to outgoing currents or output currents. Now, before starting the numerical, in the exam you should write these defining equations of Y parameters, because these are required for the reference purpose. Say, I will say this is equation A, second equation I will mark it as equation B. Now apply KCL at node VA. It's very simple. Incoming currents at node VA is only I1 and I4. So I will write at LHS I1 for I4. See, what is the formula? Incoming current is equals to outgoing current. So incoming current are flowing towards VA. So it is I1 and I4. So I have written I1 plus I4 is equals to outgoing currents are this current, this current, that is 2I1. since the value is given in terms of current, unnecessarily don't increase the notation, keep the notation as it is. So I have kept it as it is 2I1, and this one is also I3 is also outgoing current. So this is now the formula. Now after writing the node equation, next step is write equation of current in terms of voltage. Stick to the basics. Basically current, any current is voltage upon resistance. Look at I1. Look at this diagram. At this end voltage is V1. So I1 is flowing from V1 to VA. So for I1, I will write the equation V1 minus VA upon 8 plus, this is the equation of I1, plus I4. I need to write equation of I4. So equation of I4 is this current. At one end we have voltage V2, at another end VA. So it is V2 minus VA upon resistance, that is equals to 4, is equals to this equation. This outgoing current, I have made a mistake. This is incoming currents are I1 plus I4. Outgoing currents are, yeah, sorry, it is okay, 2I1 plus I3. So it is 2I1, that is 2I1. I have already this equation V1 minus VA upon 8. Same thing, this is I1 only, plus I3. Look at the diagram. At one side voltage is VA, at another side by default this terminal is grounded, so it is VA minus 0, that is VA upon 2. Now what you have to do? You have to simplify this equation. What is our expectation? What is our requirement? You need to calculate value of VA. So after simplifying, you will get value of VA. I am not going to simplify it just to save the time. So I am directly writing the answer. VA is 2V2 minus V1 upon 5. This is the value of VA. Now how to solve the problem further? What I did, I have written the equation of current. Then I have expressed every current in terms of voltage. From this, V1 and V2 are standard notations. What is the non-standard notation? That is VA. So I have calculated value of VA by simplifying this equation. VA is this value, 2V2 minus V1 upon 5. Now for the reference, I have to make use of equation A first. We have the equation of I1, which is in terms of V1 and V2. So for I1, refer the earlier equation. We have already written equation of I1, that is, I will write it over here. I1 is equals to V1 minus VA upon 8. Simply put the value of VA over here and simplify the equation. You will get equation of I1 as I mentioned earlier. I am directly writing the answers without simplification. Simplification is pretty simple. So I1 is 3 by 20 V1 minus 1 by 20 V2. Say this is equation number 1. Now what you have to do? To do the calculation of y parameters, compare equation 1, this equation, with equation A. A is the reference equation, this equation. In equation A with V1, I have term y11. In equation 1 with V1, I have term 3 by 20. So directly I will get answer y11 is 3 by 20. This is one answer. Similarly, in equation A with V2, we have y12. In equation 1 with V2, we have minus 1 by 20. So y12 is equals to minus 1 by 20. And this is the admittance. So its unit is mho. It is reciprocal of ohm. So these are the calculation of two parameters. For the next parameter, same procedure you have to follow. I will just explain it briefly. What you have to do? Now apply KCL at node V2. So at node V2, incoming currents, look at the diagram. What are the incoming currents in the diagram? At node V2, I will write it over here. At V2, incoming currents are this 2I1 and I2. This is standard notation I2. So incoming currents are 2I1 plus I2 is equals to outgoing currents from node 2 is I4 is equals to I4. Again, same technique. We have already all the equations which we have written. That is I1, put the value of I1, this value. Then we have written the equation of I4. This is the equation of I4. Again, put the value of I4. I don't have equation of I2. Let us develop it. Look at the diagram. There is no resistance. So in such cases, how to avoid the condition? There is no resistance, so I will keep I2 as it is, because later on I can simplify it using any technique. So I am keeping this term as it is. Now, just like the previous case, what you have to do? This is unknown quantity now because of non-resistance. There is no resistance. I cannot calculate value of I2. So put the value of I1, put the value of I4, keep I2 as it is, and now do the calculation of I2, because from the diagram I cannot calculate the output. This gave me the hint that I want to calculate the value of I2. So if you solve this, you will get answer I2 is equals to V1 upon 4 minus plus V2 upon 2. V2 upon 4. I am directly writing the answers. What I said, from these equations, just transfer this to I1 at the RHS. Put the value of I1 and I4 from the earlier equation. You will get equation related to I2. Now say this is equation number 2. Now compare equation 2 with equation B. B is the reference equation. This equation. Here with V1 we have Y21. Here with V1 we have minus 1 by 4. So I will get the answer Y21 is equals to minus 1 by 4 more. Then the second term is 1 by 4 times V2. This is Y22. So I will get the answer Y22 is equals to 1 by 4 times, that is 1 by 4 more. These are the answers as far as Y parameters are concerned. So what I said, if you are solving numericals for Z parameter, apply KVL, and if it is a T network, we have a ready-made formula. If you are solving numericals for Y parameters, apply KCL. Now, just like the Z parameter, there is again one shortcut techniques. If what we learned in Z parameter, if it is a T network, then we have a ready-made formula. In case of Y parameter, reciprocal of T is Y network in electronics. So the nature of pi network is like this. So if the given equation contains pi network, we have a ready-made formula to calculate the Y parameter. What are these formulas? I am not writing any notations. Notations are standard as we have discussed earlier. This is current, incoming current I1, this is output current I2, this voltage is V1, this voltage is V2, and so on. There are two nodes. This is node 1, this is node 2. By default, bottom line is connected to ground. So formulae are Y11 is, I will assume certain values, say this is 100 ohm, this is 200 ohm, this is 200 ohm. And if it is required to calculate Y parameters of this network, so what I said, you don't have to use KCL or KVL and nothing. There are ready-made formulae. Y11 is sum of admittance connected to node 1. So it is summation of admittance connected to node 1. Do remember, Z is the notation to represent impedance, whereas reciprocal of Z, that is 1 by Z, is denoted by Y. It is known as admittance. So what is the formula? Summation of admittance at node 1. At node 1, 200 and 100, these two values are connected. But these are the values given in terms of ohms. That means these are impedance. So how to calculate admittance? It is 1 by 200 plus 1 by 100. Take the reciprocal of this impedance. This is the common mistake in the exam. Avoid it. Do remember, admittance is reciprocal of impedance. Values are given in terms of impedance. So I have written 1 by 200 plus 1 by 100. This will give me value of Y11. Similarly, formula for Y22 is sum of the same formula, summation of admittance connected at node 2. Now at node 2, what are the admittance connected? I have considered the same values, so you might be thinking you are getting the same answers, but if the values are different, definitely you will get the different answer. So it is summation of admittance connected to node 2. To the node 2, 100 ohm and 200 ohms are connected. So it is again reciprocal of 1 by 200 plus 1 by 100. You will get value of Y22. Then Y12 is equals to Y21 is negative of, do remember this, negative of common admittance between node 1 and 2. Between node 1 and 2, resistance is 100 ohm. Formula is negative of common admittance between node 1 and 2. This is impedance or resistance. So admittance is reciprocal, so it is minus 1 by 100. This is the way how you can calculate the Y parameter. Simply keep in mind, if it is a T network, use Z parameter. If it is a pi network, don't do any calculations, directly memorize this formula. These are simple formulae, so you can directly write the answer. If it is not pi network, apply KCL for y parameters. The next part is what I explained up till now about the calculation of z and y parameters. If suppose in the exam h parameter is asked or abcd parameter is asked, then how to do it? You don't have to follow any other methods. I will tell you simple tricks. Simply calculate z parameters. If suppose in the question it is asked you calculate h parameters, first calculate z parameters. You will be getting some answers. I have already explained you how to do the calculation of z parameters, as well as I have created a separate video on calculation of z parameters. So after calculating z parameters, these are the formulae to calculate h parameters. Simply put the values of z like z11, z22 minus z12, z21 upon z22. This will give the value of h11. Similarly, only a formula of h11 is lengthy, otherwise remaining formulae are not at all lengthy. So if you make use of this set of formula, you will get the answers in terms of h parameters. Suppose ABCD parameters are asked, again do the calculation of z parameters and make use of this formula. A is z11 upon z21 and so on. Likewise, you can calculate other values like A, B, C and D. So this is the way how to solve numericals as far as the network parameters are concerned. So prepare the derivations of all these parameters. I have told you the simple trick how to prepare the derivations, as well as I have created a separate video on derivations of each and every parameters. Do watch that video, and I have already explained right now how to solve numericals on each of the parameters. Out of that, I have created video for numericals on z parameters. So if you know how to do the calculation of z parameter, you can calculate all these types of parameters. Now the remaining last part of this unit is the driving point or transfer function. I will write the heading like this: driving point impedance or transfer function impedance. This is the most important part as far as this unit is concerned, and it is pretty simple. You should not skip this part. Again, I have created a separate video. The name of that video is pole zero plot. Do watch that video. This is the most important part and pretty simple. Right now, I will just explain what is this. Any equation, any circuitry will be given, and it will be asked to calculate driving point impedance and plot the pole zero diagram. How to do it? There are simple formulae. Every circuit consists of three basic components: R, L, and C. You have to convert the things into Laplace domain. For example, R remains as it is. That means resistance is not affected in Laplace domain. L, that is inductor, is expressed as S into L. S is the notation used in Laplace. L is the value of inductance. C is the value of capacitance. It is transformed as 1 by SC. I will tell you, I will explain one numerical how to do these calculations, because this is important part. Suppose the given diagram is like this. This is the value of resistance, which is 4 ohm. Then in series with this, there is one inductor of 1 Henry. Then again one resistance of 1 ohm, and last component, one capacitor of value 1 farad. If it is asked to calculate the driving point impedance of this network and plot the pole zero diagram, how to do it? Right now I have explained you the formula. This is the resistance, so it remains as it is. For inductor, what is the formula? Inductor is expressed, or inductor is converted into Laplace as S into L. Make the thing simple. Whatever value of L is there, L is 1 Henry in this case, multiply it with S, so it is S into 1. That becomes S. I will write the new value over here. This is resistance, it remains as it is. For capacitor, we have the formula 1 upon SC. So write it like this: 1 upon S into value of capacitance. Value of capacitance is 1. So this simply becomes 1 upon S into 1. So it is 1 by S. This is the converted diagram. First step is we need to convert the given diagram into Laplace domain by using this formula. Keep resistance as it is. Now, I have to do the driving point impedance. Keep in mind, this is the input part. Always and always for driving point impedance, try to do the calculations from this part. I will mark the arrow at this part and write the notation as Z in of S. Why S? Because we are doing the calculations in Laplace domain. Don't get afraid. No extra formula of Laplace is required as far as these numericals are concerned. Only these two formulae. Okay. Now, when you are looking from this end towards the network, start doing calculations from the other end. That means I will be doing calculations from this end. Now, there are two different wires. We already discussed this concept several times. Let us discuss it once again. Whenever there are two different wires, the things are in parallel. Whenever there is a single wire and two elements are shown, they are in series. So, these are two different wires. So, they are in parallel. So, first combination I will write it as 1 parallel 1 by S. I hope you are aware how to do this parallel combination. It is very simple. 1 into 1 by S upon 1 plus 1 by S. So after writing this, you will get the answer like this: 1 into 1 by S upon 1 plus S. Then once you will come to know what is the first calculation, it is parallel combination. Next is series. So by default, these two are in series. So if I will combine these two, I will get the answer. Since they are in series, it is 4 plus S. So final driving point impedance, I will write it like this: Z in of S is equals to this value 4 plus S plus this parallel combination. Just now I have written the answer 1 into 1 by S. That means simply 1 by S upon 1 plus 1 by S. Simplify this. How to simplify it? This 4 plus S remains as it is, plus 1 by S, keep it as it is. For this, take S as LCM, so it becomes S plus 1 upon S. So cancel out these terms. So simply equation becomes 4 plus S plus 1 upon S plus 1. Again take LCM, that means multiply 4 by S plus 1, multiply S by S plus 1. So this becomes 4 into S plus 1 plus S into S plus 1 upon S plus 1. So it is 4S plus 4 plus S square plus S upon S plus 1. So this equation, I will write it like this. After simplifying, I will get the equation. This is S square plus 5S plus 4 upon, it is S plus 1. This is the answer of driving point impedance Z in of S. One important concept. For this equation, do the calculations using calculator. Don't calculate the roots manually. When you are doing the calculations, if you have older version of Calc, then always and always while calculating the roots, check the right top corner of Calc. If you are getting the notation like this, REC, that means roots are imaginary. For example, if you enter all the values and if you press equals to sign, you are getting answer 1. And if on the top right hand side corner you are seeing this symbol REC, then again press equal to sign, so you will get the value of J. So let us say answer is 1 plus J1, like this. But keep in mind, watch this notation. If you are older versions of calculator, for new versions, when the roots are complex, directly you will get the answer in terms of complex mode. Alright, presently if you do the calculation of these roots on the calculator, first bracket is S plus 1.38, second bracket is S plus 3.6, denominator remains as it is, S plus 1. There are simple roots, no complicated roots. Now this is one part. I have done the calculation of driving point impedance. Suppose in the question admittance is asked, very simple, don't get afraid. Calculate impedance only, take the reciprocal of this, it will be driving point admittance. That means if admittance is asked, directly I can write this answer S plus 1 upon S square plus 5S plus 4. Now remaining part, if it is asked to draw the pole zero diagram, how to do it? Again, it's not at all tough. Mark this axis as real axis, mark vertical axis as imaginary axis. Presently there are no imaginary values. Now one common mistake, this first bracket is S plus 1.38. Roots of numerator are called as zeros. These are denoted by Z1, Z2, etc. and these are represented by small circle. Whereas roots of poles are denoted by P1, P2, etc. and they are represented by notation cross. one common mistake, as I mentioned right now, this first bracket is 1 plus 1.38. So its value, that is, this is in the numerator. So roots values are in terms of zeros, but change the sign. First 0 is minus 1.38. In another language, whatever values you are getting on the calculator, those are zeros. So Z1 is minus 1.38, Z2, again in the bracket we have S plus 3.6, change the sign. So it becomes minus 3.6. For the pole, this is the denominator. For the pole, again we have S plus 1. So first pole is at minus 1. How to plot it? Very simple. This is the origin. First pole is at minus 1. So let us say this is the value of minus 1. Mark it by the cross. This is first pole P1. What about zeros? First 0 is at minus 1.38. Let us say somewhere here I am getting value minus 1.38. This is value of Z1. Zeros are denoted by small circle. Second pole, second zero is minus 3.6. Somewhere here, let us say value is minus 3.6. Since the values are negative, I am drawing on left hand side. So it is minus 3.6. This is the second zero, that is Z2. So rightly I have mentioned, you have to watch this video related to the pole zero plot. This is the most important part from this unit. So dear students, that's it for this unit, that is two-port network parameters. So thank you, thanks a lot.